everyone, today we are going to continue our integration series. So this is your integration series part 2. In this part we will discuss various integral forms and how to solve these forms with basic tricks. So stay tuned. Suppose you have an integral of the form that ax plus b and in under root there is cx plus d. Okay. So this function, in these type of functions, what you have to do is, you have to follow a very basic procedure that I am going to tell you here. Firstly, what you need to do is, you need to convert this number into this form only, okay. So whatever is in the square root, it has to be represented in this way only. So let's say ax plus b is there. So what I am going to write ax plus b, I am going to write ax plus b is equal to lambda times cx plus d plus mu. Okay, so this is a very simple procedure and you will be able to understand this questions with the example. So I am going to give you a very basic example which will help you to understand. Suppose you are having a question 7x minus 2 and in square root you have 3x plus 2. So this type of question can be easily tackled with the trick that I have told you. So what you are going to do is, you are going to convert this number into this form. So let's see how I am going to write it here. I am going to write 7x minus 2 is equal to lambda times 3x plus 2 plus mu times 1. Okay. So I'll write 7x minus 2 as lambda times 3x plus 2 plus mu, where lambda and mu are constants. Lambda and mu are constants. So what we are going to do is, I'll write 7x minus 2 is equal to 3 lambda x plus 2 lambda plus mu. Okay. So in this equation we are going to compare the coefficients. Okay. So what is the coefficient of x here and what is the coefficient of x here? So here it is 3 lambda is equal to 7. Lambda turns out to be 7 by 3. Okay. Similarly, we are going to compare the coefficients of constants. Okay. So here 2 lambda plus mu is nothing but minus 2. Okay. So lambda is 7 by 3. So 2 into 7 by 3 plus mu is equal to minus 2. So mu turns out to be minus 2 minus 14 by 3. So in this you will take LCM. LCM would be 3. 1 times 3 is 3. So minus 2 times 3 is minus 6 minus 14 and it will be minus 20 by 3. Okay. So the same thing you will put it here. So I am going to continue this question from here. So here it is integral. How I am going to write 7x minus 2? 7x minus 2 is nothing but lambda times 3x plus 2 plus mu. Okay. And square root of 3x plus 2 will come as it is. Okay. So now I am going to solve it here. Integral. Now this will come to be lambda times 3x plus 2 raised to the power 3 by 2. Okay. Plus mu times 3x plus 2 raised to the power 1 by 2. Okay. I know that few of you won't be able to understand this step, so I am breaking it down here. So what I have written here is, you know that square root of x is nothing but x raised to the power 1 by 2. Okay. And there is another property which we have used here, which is nothing but x raised to the power m multiplied by x raised to the power n is equal to x raised to the power m plus n. So these two properties have made us arrive at this position. Okay. Now I am going to use the values of lambda and mu. So lambda is nothing but 7 by 3. Okay. So it will be 7 by 3. 3x plus 2 raised to the power 3 by 2 is nothing but 3x plus 2 raised to the power 5 by 2 upon 5 by 2. And this 3, the coefficient of x would come in the denominator. Okay. So mu is nothing but minus 20 by 3. So I'll write minus 20 by 3. So what is the integration of 3x plus 2 raised to the power 1 by 2? It is nothing but 3x plus 2 raised to the power 3 by 2 upon 3 by 2, and this coefficient of x would come up in the denominator. Okay. Now I'll solve it here, and here you will have to remember that there is a constant. This is integrating constant. Whenever you will remove the integral sign, you will apply the constant here. Now you will get, what you will get is 2 times 7 is 14, okay, 3 times 5 is 15, into 3 is 45, okay, upon 45, 3x plus 2 raised to the power 5 by 2 minus, now 40 upon 27, 3x plus 2 raised to the power 3 by 2 plus c. So this is how you are going to solve a complex form of integral into a very basic thing, right? So I hope I have made it simple for you. Now we are going to see the another integral form. Suppose we are having this integral form, integral ax plus b upon root cx plus d dx. So in this form, what we have applied in the previous form, we'll apply the same thing here. What I'm going to write here is, I'm going to write ax plus b is equal to nothing but lambda times cx plus d plus mu, where lambda and mu are constants. So whatever is in the square root, you will represent the numerator in that form, right? So this is very simple. I'll give you a very basic example. It will really help you to understand. Suppose you are having this form as the question, right? In this, the numerator is square root free, but in denominator the function is in square root. So how you are going to tackle that, I am going to tell you here. What you are going to do is, you are going to write 8x plus 13 is equal to nothing but lambda times 4x plus 7 plus mu, where lambda and mu are constants. So what I am going to write this as 8x plus 13 is equal to 4 times lambda x plus 7 times lambda plus mu. Okay. So what we are going to do is, we are going to compare the coefficients of x and we are going to compare the constants. So coefficient of x is 4 lambda and here it is 8. So lambda turns out to be 2. Okay. Now 7 lambda plus mu is nothing but 13. Lambda is 2, so it is 14 plus mu is equal to 13. So mu comes out to be minus 1. Mu comes out to be minus 1, lambda comes out to be 2. Now we are going to tackle this question from here. Okay. So here it is equal to integral. How I am going to write 8x plus 13 is lambda times 4x plus 7 plus mu upon root 4x plus 7. Okay, and this is your integrating element dx. So lambda here is 2. Okay, so this 4x plus 7 is there in the numerator and root 4x plus 7 is there in the denominator. So I'll write root 4x plus 7. Okay, root 4x plus 7 and plus mu is nothing but minus 1. So minus 1 upon root 4x plus 7. Okay, root 4x plus 7, and here is the dx. Okay, so now we are going to integrate this function. So it is nothing but 2 times 4x plus 7 raised to the power 3 by 2 upon 3 by 2, and the coefficient of x4 will come out here. Okay, now minus 1 times, so minus 1 times is okay. So 4x plus 7 raised to the power minus 1 by 2. So it would be nothing but 4x plus 7 raised to the power plus 1 by 2 upon 1 by 2, and the coefficient of x would come in the denominator. And after writing this, I am going to write a constant c. So remember, whenever you are removing the integral sign, it is very important to add integrating constant. Okay, so 2 times 2 is 4. Okay, and it will also cancel out. So here the only thing will remain is 3. So what we are going to write is as 4x plus 7 raised to the power 3 by 2 upon 3. Okay, so this is 2 times minus 4x plus 7 raised to the power 1 by 2 upon 2 plus c. So see, This is very simple thing. If you will apply the basic logic, you will be able to solve any question of any form. So now we are going to understand that how can we tackle if the integral is in this form. Okay. So now we will see that if sine has any power and let's say cos has any power, how we are going to solve this integration problem. Suppose you have the question of integral sine square x dx. Okay. So how are you going to solve this question? So I'll give you a brief view, then you will be able to understand this better. Okay. So you need to understand the basic trigonometric identity in order to solve this question. So what is it? Let's try to find out. You know that 1 minus cos 2x is nothing but 2 sine square x. Okay. So I can write sine square x is nothing but 1 minus cos 2x by 2. Okay. So you will apply this identity here. What you will get is, you will get 1 minus cos 2x by 2 dx. Okay. You will get 1 minus cos 2x by 2 dx. Now you will again write this as 1 minus 2 minus cos 2x by 2 dx. So now you will get answer as x by 2, okay, minus 1 by 2 times, what is the integral of cos x? Integral of cos x is sin x. So the integral of cos 2x will be sin 2x, but in denominator you will get 2, the coefficient of x. So it will come up here. So when you are removing the integral sign, you will write a constant here. Okay. So finally you will get the answer as x minus 2 minus 1 by 4 sin 2x plus c. So this is a very basic question. So we'll understand. So similarly, we are going to understand about integral of cos square x dx. So suppose you are having this question. So what you are going to do is, you are going to apply a basic trigonometric identity. You know that 1 plus cos 2x is nothing but 2 cos square x. Okay. So you will write cos square x as 1 plus cos 2x by 2. Okay. So you will apply this question here. You will apply this identity here. So here it is 1 plus cos 2x by 2 dx. Okay. So you are going to break it down like this. Integral of 1 by 2 plus cos 2x by 2 dx. Okay. So 1 by 2 integration is nothing but x by 2. Okay. And plus 1 by 2, what is the integration of cos x is sin x. So the integration of cos 2x will be sin 2x, but in denominator you will get the coefficient of x, which is 2 plus c. So the answer to this is nothing but x by 2 plus sin 2x by 4 plus c. So this is a very basic concept that I have simplified here. Now suppose you are having this question. So how you are going to tackle this question with the available information that we have? So let's see. Okay. So you know that there are 3 cos functions available here: cos 2x, cos 4x, cos 6x. So what you are going to do is, you will analyze that what are the 2 smaller functions. Let's say 2x and 4x is less than 6x. So you will take this as a combination. So you will see that how I am going to tackle this question. Okay. I am going to write this question as 1 by 2. What if I am dividing by 2 and what if I am multiplying by 2? Thus the equation will remain same. I will write this as cos 2x cos 4x cos 6x we can take in the bracket and dx. Okay. So what it is? 2 cos A cos B. We need to understand the basic trigonometric identity of 2 cos A cos B. What is 2 cos A cos B? 2 cos A cos B is nothing but cos A plus B plus cos A minus B. Okay. So I am going to apply this property I'm going to apply this property here. Okay, I'm going to apply this property here. So you will get 1 by 2 times integral of 2 cos A cos B will turn out to be cos A plus B plus cos A minus B, which is 2x. Okay, and in multiplication you will get cos 6x dx. Okay, so how you are going to apply how you are going to tackle this question now from here? What you will do is integral, you will get cos square 6x square 6x plus cos 2x cos 6x dx. Okay, now what you are going to do is you are going to write cos square x as 1 plus cos 2x by 2. So you will get 1 plus cos 2x. So 2 times 6 is 12. 1 plus cos 2x by 2, right? And here again what you are going to do is you are going to divide by 2 and you are going to multiply by 2. So you will get 2 cos A cos B again, right? 2 cos A cos B again. So you will apply this property again. So here you will get cos A plus B, which is cos 8x plus cos A minus B. You will get cos 4x. Okay. So in that way you see that this question has been reduced to a very basic identity that we have already discussed. So I am going to write this as 1 by 2. What is integral of 1 by 2? It will be x by 2. Okay. What is the integration of cos 12x? It will be sin 12x by 12 plus 1 by 2. What is the integration of cos 12x? Is sin 12x upon 12. Okay. Now it will be plus 1 by 2 times. Okay. What is the integration of cos 8x? Cos 8x is sin 8x by 8 plus sin 4x by 4. Okay. So this is a simple game of multiplication now, nothing else. So what I am going to write here as and plus integrating constant. So it is very important to remember that whenever you remove the integral sign, you got to add this integrating constant. So you are going to write this as nothing but x by 4 plus 1 by 12 into 4 is 48 sin 12x plus 4 times 8 is 32. So 1 by 32 sin 8x plus 8 times 2 is 16 plus 1 by 16 sin 4x plus c. So this is how your solution looks like. Now I am going to give you a very solid trick that you will like the most. So suppose you are having this question tan x, tan 2x, tan 3x. Okay, I am going to give you a trick so that you can solve these type of questions in blink of seconds. So what that trick is that whatever the biggest tan angle will be, right? So you will write this as tan 3x. Okay, so you will take the biggest angle as positive while the smaller angles will turn out to be negative. So minus tan 2x minus tan x dx. So there is a proof associated with it, but what I am going to tell you is you need to remember these type of tricks. It will really help you to solve the questions with very ease and with very basic properties. Okay, so you know that integral of tan x is what? As I have earlier told you in my part 1 that you are going to assume that tan x sin by cos, right? Sin by cos. So whatever will be in the denominator, you will write it as minus log cos x plus c. So right, so this is very simple thing now. So the integration of tan 3x will be nothing but minus log cos 3x upon 3 minus, and then minus minus will turn out to be plus log cos 2x by 2, and then it will again turn out to be plus log cos x plus c, right? So this is as simple as that.